So we'll continue the chapter 8 review on chemical composition, and we have done all the exercise from 1 to 12. So we'll start at 13, and that's the last problem of this chapter 8 review. So here we are, chapter 8 review, question 13. And so notice how it is similar to your question 24 in the homework 8. So you can use this to solve the question 24 of homework 8. So it's a peculiar problem, as you can see. 3.846 grams sample of Cr2O3 solid, so it's a chromium oxide, is converted completely to another chromium oxide by adding oxygen. So we are adding oxygen only. The new oxide has a mass of 6.679 grams. And they ask you to add subscript to correctly identify the empirical formula of the new oxide. So this sentence here is a bit misleading. Add subscript is not really what you will need to do here. It's much more complicated than that. So it's not just a matter of adding the subscript. So we have this first sample of identified chromium oxide, it's Cr2O3, and we have its total mass. And because we have the formula, we can find the amount of chromium versus the amount of oxygen there is in that sample. And then the new oxide, we have its total mass, but it's a new oxide only by adding oxygen. So the only thing that changed between the previous oxide, the Cr2O3 and the new oxide is the fact that there is more oxygen. The amount of chromium has not changed. So that will be useful. And so let's start by finding the amount of chromium there is in the new oxide by finding the amount of chromium there is in the old oxide, right? Because it stays the same. Here we have the formula and we have a total mass. So to find the mass of chromium only, we need to first find the mass percent of chromium in this Cr2O3, right? When we find the mass percent of chromium in this compound, then we can find, the percentage of this total mass that is due to chromium only. So let's find the mass percent composition of Cr2O3, but just the one for chromium. So for this, we will need the molar mass of this compound, Cr2O3. So let's look at the periodic table to find the molar masses we need. We have chromium here with 52, exactly 52 grams per mole. And then oxygen, 16.00 grams per mole. So 52 and 16. So we have 2 chromium. So we will do 2 times the molar mass of chromium. So 2 times 52.00 grams. And we have 3 oxygen. So we'll add 3 times the molar mass of oxygen, 16.00. And so that leads to a total of 152.00 grams per mole. So here it is important to keep all the decimals. The periodic table gave 2 decimals for each molar mass, and we are adding them. So we keep 2 decimals in the end for the molar mass of Cr2O3. So we want to find the mass percent composition of Cr2O3, and in particular, the mass percent of chromium in that compound. So let's write the formula for that. The mass percent of chromium in Cr2O3 is the mass of chromium on top, the mass of chromium in that compound, over the molar mass of the compound. So if we plug in the values, we get, so we will have to plug in the values here. So the mass percent of chromium in Cr2O3 is the mass of chromium, and the mass of chromium is 2 times 2, that's times here, 52.00. That's the contribution in mass of chromium. And then the molar mass we just calculated, it's 152.00 grams. You know, the grams cancel here. And we multiply by 100. So let's show how the mass cancel. So in the calculator, you do 2 times 52 divided by 152 times 100 equals 68.42. And there is a 1 after that. But if you look at what we have given, we have 4 sig figs in the molar mass of chromium, and then 5 in the chromium molar mass, you know, the chromium oxide Cr2O3 molar mass. So 4 sig figs is what we need to keep. So we can drop the 1 after the 2 here, and it's 68.42 grams, percent by mass of chromium in Cr2O3, in Cr2O3. So now that we know the mass percent of chromium in Cr2O3, we can calculate the mass of chromium in this given mass of the chromium Cr2O3, right? We have the total mass, and using this percentage, we can find the mass of chromium only. So we will calculate then the mass of chromium in the sample of 3.846 grams of Cr2O3. And we will use the fact that in 100 grams of Cr2O3, so in 100 grams of Cr2O3, we have 68.42 grams of chromium. That's what it means. So we will use that now as a conversion factor. And so we start the calculation with the given amount of chromium oxide, you know, Cr2O3. So this is the given amount here we will start the calculation with. And we will use the fact that in 100 grams of Cr2, so Cr2O3, we have 68.42 grams of Cr, right? We use the percentages here as a conversion factor that gives the mass of chromium in 100 grams of the compound. So in the calculator, we do 3.846 times 68.42 divided by 100. And the answer is 2.6314, etc. So let's think about sig figs. We have 4 sig figs in the given amount, 4 sig figs in the percentage, you know, in the grams of chromium. And the 100 is exact here. It's coming from a percentage, so it's exact. So we need to keep 4 sig figs. So we keep the 2, the 6, the 3, and the 1. What comes after the 1 is a 4, so we drop the 4, and it's 2.631 grams of chromium in that sample of chromium 2O3. But as we said, when we are making the new oxide, it's only by adding oxygen. So this mass is also the mass of chromium in the new oxide, because we only added oxygen from there. So we have the mass of chromium in the new oxide. So now we need the mass of oxygen in the new oxide. So let's calculate the mass of oxygen in the new oxide. So we know the mass, the total mass of the new oxide. So we can use that and then subtract the mass of chromium we just calculated, and the difference is only due to oxygen. So if we do this, mass of new oxide minus the mass of chromium, will get us the mass of oxygen in the new oxide. So the mass of the new oxide is 6.679. So 6.679 grams minus the mass of chromium we just calculated, 2.631 grams of chromium equals, and the difference will be the mass of oxygen. So 6.679 minus 2.631 is a 4.048. And that's grams of oxygen. Oops. Of oxygen in the new oxide. So we have the mass of oxygen in the new oxide, the mass of chromium in the new oxide. So now we can just do the usual procedure that we do to find the empirical formula of compounds, which is change those into number of moles, right? Because to get a formula, we need number of moles. Mass don't work for that. So let's use the mass of chromium and of oxygen to find the number of moles we have. So let's start with chromium. We have 2.631 grams of chromium. And we know there is, so in 1 mole of chromium, there is a 52.00 grams, right? It's the molar mass we find in the periodic table. So we do 2.631 divided by 52, and that's it. So 0.050596. So let's think about that. We need 4 sig figs according to the mass of chromium and molar mass as well. So the 1 mole, of course, is exact. So we need 4 sig figs. The 2 zeros there are not significant. So we keep the 5, the 0, the 5, and the 9. What comes after the 9 is a 6. So this is going to be 60 here. So that's how we would round. And the unit is mole of chromium. And that's in the new oxide. Huh? Just let's specify that. So that's the moles of chromium in the new oxide. Let's do the same thing with oxygen. Oxygen, we have 4.048 grams of oxygen. And we know in 1 mole of oxygen, we have 16.00 grams, right? That comes from the periodic table. So 4.048 divided by 16, and it's 0.253. We need 4 sig figs, so we need to add a 0 here to say 4 sig figs like we had in the given amounts. And that's the moles of oxygen in the new oxide. So we have our number of moles. So the procedure from there is to write a pseudo formula, right? If you write a pseudo formula using those numbers of moles as a subscript, then you will have a pseudo formula. So that makes this pseudo formula being chromium 0.05060. And then the subscript for oxygen is 0.2530, right? We use those number of moles as subscript. Of course, we cannot leave the formula like this. And so what we do is divide each subscript by the smallest of the 2 subscripts. And here the smallest value is this 0.05060. So we will divide both subscript by that. And so when we divide by this, we get that. So that's going to make a subscript of 1 for chromium. And then when you do 0.253 divided by 0.05060, it's a subscript of 5 for oxygen. And those are 1 and 5 are exact, are whole numbers. So then the formula can be left like this. So that means this is our empirical formula. We can write that the new oxide has an empirical formula of CrO5. And so you can see why saying that you add subscript to find this formula is really misleading here, because the subscript really have nothing to do with the previous subscript of Cr2O3. So that's how you solve this problem. And that ends the chapter 8 review.